Practice problem 2. A 10 kg object is pushed across a level floor with a horizontal force of 25 newtons, moving at a constant speed. What is the magnitude of the frictional force acting on the object? Also find the normal force. Okay, well, let's go over the solution. We're given that the mass of the object is 10 kg. And we can see from the free body diagram that the two pairs of forces are acting in the opposite directions. So they cancel each other out because it's implied that since it's a constant velocity, there's no acceleration acting on the object, which means the net force is 0. Now, we know that the applied force, or the force of the push, is 25 newtons, which is given. Since the net force is 0, it means that the horizontal forces must balance, they must cancel each other out. So the frictional force is equal to the applied force, which is 25 newtons. So that's the answer to the first part of the problem, which asks us to find the frictional force. That's 25 newtons. For the second part of the problem, they ask us to find the normal force acting on the object. Now, we know that the normal force and the weight force are acting in the opposite directions. And since there's no net force, which is implied by the constant velocity again, we know that they both must be equal in magnitude, and they must act in opposite directions according to Newton's third law. So, we just equate them both and find them using the mass, which is 10 kilograms, and the acceleration, which in this case is g, and that's 9.8 meters per second squared. So we know that force equals mass times acceleration. So when you plug the numbers into this equation, you get the force to be 98 newtons. So the normal force, which is also equal to the weight force, is 98 newtons. Here's the free body diagram for reference again. Over here, the normal force is F sub of n. The weight force is F sub of W. The applied force is F sub push. And the frictional force is F sub F. And this is the box right here, which is a small dot.